Okay, on the bench today we have a PlayStation 5 power supply. It is model ADP 400ER. Purchased it on eBay. Is not working. Just so I could have a go at getting it back up and running. So, right, first things first. We have 2 screws on these. So, oops, I'll get them out. Right, now I believe this bit is a bit of a pain in the backside. Because after the 2 screws, the rest of it's basically just clipped together. And quite tightly, I believe. Getting somewhere. At last. You can see right off the bat there's a bit of a skid mark. Just there. Yeah. Something's popped. Right. So, get this out. First things first, I'm just going to check the big caps. Make sure there's no voltage. I haven't actually even tried to turn it on. I was just taking the seller's word for it. So, let's check the voltage on these. Make sure there's nothing there. And yeah, that's fine. Nothing there at all. So it should be safe enough for me to work on. Yeah. Right. Well, that MOSFET's definitely done for, I think. I've got that continuity mode. And check for short. Yep, shorted. And its neighbour. Yeah, completely shorted. What else? Well, check the fuse. It's intact. And fusible resistor. And that's open. So that's gone as well. The question is that all that went? I'm not seeing any signs on the board. Any other physical signs of damage to anything else other than that MOSFET in particular. Right, I think what I'll do then, I'll replace these, replace that resistor, which I believe is a 0.1 ohm resistor. Right, okay, that's what we'll do first. Right, I'll get the desolder gun warmed up and I'll get those components removed. Right, this is up to temperature. Right, so we'll get these 2 removed. bent over, which is a pain in the backside. One, two, back out. There we go. Double check these are in fact shorted. And double check this. Yep, still reading open line. So they're definitely gone. And I do have the resistor to replace that one, and a couple of new MOSFETs to fit in the board. Try and bend these legs to the same shape. Yeah, that's close enough. So no evening shot there. Should do the job. Start with a resistor. Oops. Flux everywhere. Actually, no, that's tinned up fine. Should be able to just go straight in there. Make a big zero of this. Solder on iron. That'll hold it in place. And a little bit of flux. running. Right, a bit done. Looks fine. I think what we'll probably have to do is check the DAP and make sure that it hasn't gone at the same time. To take notes somewhere. The readings that we should get in diode mode from that IC. So I'll tell you what, I'm going to switch over to the microscope. Right, diode mode. Red probe on ground. Right, and there's pin 1. That would be pin 1 here. What we got? 0.7, which is fine. 0.59 is fine. No, pin 3. Just 0.69, which should be fine. Pin 4 is ground. Pin 5, 0.67 is fine. 0.66. Pin 7 is no connect. So let's open line that one. Pin 8, 1.36, fine. Pin 9, 1.16 is fine. And pin 10 is fine. Pin 11 is fine. 12 should be no connect, yep. 13.68 is fine. 14.64 is fine. 0.7 on 15 and 16 is 0.69, which again is fine. So the readings coming from the DAP are basically the readings that would be expected. So I'm thinking we should be good to give this a little bit of a test, and hopefully whatever caused those MOSFETs to go bang in the first place is no longer an issue. Just about to find out. Right, okay, we're good to give this a test. Move this along a little. Move the meter into shot. Voltage. DC. Now I've got the electronic load set up to draw 5 amps. And let's see what happens. Right, we are plugged in, and yeah, we're getting 12 volts on the load. So I'll just confirm that with the meter there. There we go, 12.12 volts. So that seems to have done the trick. Nothing else is failed in the supply by the looks of it. Right, as you can see, that's us up to 13 amps, which is basically the highest I can go with this. It's only rated up to 150 watts. But you can see it's running fine. You would have seen the voltage there. Does look low, but that's just lost through the leads between the supply and the load. But as you can see there, 12.6, 12.06. So yeah, that's running fine. Just unplug this. Before I go messing with anything, I'm just going to discharge the large caps. Of course I could have unplugged it and left the load supplied, and it would have drawn any remaining voltage for these caps. Right, just double check that before I start sticking my fingers anywhere. Yeah, 15 volts, that's fine. Right. Right, so the only thing that went in this supply then was 2 MOSFETs and the 0.1 ohm resistor. Didn't have to replace anything else, it's definitely running fine under load. So yeah, it's good to go. And I wouldn't recommend for anyone to go just splitting open their power supply and sticking their fingers in there. These are 450 volt caps. When this is running, there's nigh on 400 volts across there. So that'll give you a bit of a nasty one. So if you're not experienced working in and around high voltage and power supplies, then I wouldn't recommend it. But right, that's this one back up and running. So I'll get it back in its case, and that'll just probably sit as a spare. Right, so I'm going to end this video here. Supply back up and running. Both these MOSFETs completely shorted, and this resistor, which is a fusible resistor, was open and was being replaced. And that was basically that. I tested it up to up to 13 amp load, which is the max at 12 volts that I can load it up to. I believe that's plenty for the PS5. I'm not sure what it actually runs at, but I'd be quite happy to use this supply in a machine. Right, so if you liked this video, please click the thumbs up. If you want to see more like it, then subscribe to the channel, hit the bell notification icon, you'll be notified anytime I upload new content. Thanks very much for watching. Cheers.